The next thing we're going to talk about is the median. And you may remember that the median is the score that if you were to order your numbers from smallest to largest, it divides the scores precisely in half. So that's this definition here. The key, though, is you have to order your scores. If you don't order your scores, you're not going to be able to find the median, right? So if all the numbers in a set of scores are ordered from smallest to largest, the median is the number, okay, it's that number occupying the middle rank. So it's the middle score, such that half of the numbers fall below it and half fall above it, right? It's splitting them right down the middle. So let's look at some examples. Here we have a data set. I don't know if it's a sample or a population. Could be a really small sample, or it could be a really small population. Regardless, this is our data set. And what we want to do is we want to find the score that splits the distribution in half. So here, 5 is the median because there are 2 scores below it and 2 scores above it. So that splits it in half, so we say the median is 5. All right, well, that was easy. What if we change this 9 to a 99? Does that change the median? No, because it didn't change the fact that this 5 was in the middle. It didn't change the score that was at that middle address. It did change something, right? The 99 is different from 9, but it had no influence on the median because the order of these numbers stayed the same here. Okay, so 5 is still in the middle. What about this situation? That was kind of easy. You see where the middle is. But what about this? Here, there really is, you can't say that 4 is the median, because if you said 4 is the median, that would mean you'd have 2 below and 3 above. Similarly, you can't say that 5 is the median, because then you'd have 2 above and 3 below. So what do we do in a case like that? Well, we have to take or identify the 2 scores that are in the middle, because do you agree that these 2 scores are in the middle? You've got 2 below and 2 above, so that means these 2 scores are in the middle. All we have to do is take the mean of these 2 scores. So if we wanted to calculate the mean of 4 and 5, 4 plus 5 is 9, divided by 2 is 4.5. So the answer is 4.5. Okay, and now what we can see is if we have a median of 4.5, okay, so right here, right, it's just the mean of these 2 scores. Then we have 1, 2.5 scores below and 1, 2.5 scores above. So 4.5 is the median, even though there is no number in your data set that's 4.5. Well, that shouldn't freak you out too much, because it's like saying the average number of children, that a typical family has in the United States is 2.6 or 6.2 in Utah. That's my joke. Get it? Okay, so how you can't have 6.2 children? Well, that's true, but when you're calculating an average, that's no longer true, right? It's saying, well, the average is 6.2, even though you cannot have 6.2 children in reality. So same thing here. Okay. Properties of the median. Here's some things you may or may not have known about the median. So the first thing is that we do not consider the median to be very sensitive. Just look at this guy. So he's the median. He is very insensitive. And the reason why we don't consider the median very sensitive as far as averages go is because the median doesn't care what the numbers equal. Couldn't care less. The only thing the median cares about is what number is located at that middle rank. What is the middle score? And the other numbers can be anything. It doesn't care. It only says who is at the middle. That's the median. So way of example, if we have this data set, median would be 9. Why? Because we have 3 scores below it and 1, 2, 3 scores above it. So it's right smack dab in the middle. That's the median. What if I changed one of the numbers here, so 15, and plugged in 666? You all know what that's supposed to symbolize, right? By the way, I got to tell you this. I'm a horror movie fanatic. I love horror movies. And I started up this side business a couple of years ago, and I got my business license in the mail. And guess what my business license number is? 666, which means there's no way it can fail because that's my favorite number, right? It's got to work. Okay, that was an aside. Let's get back to this. All right, so we changed one of the numbers and we changed it quite dramatically. Did it change the fact that the median is 9? No, because at least it didn't change the ranking of the numbers, right? Number 9 is still the number that's in the 4th place. All right, it needs to be in the 4th place. If you have 3 above, 3 below, that means this is in the 4th place. All right, so the fact that 9 is still the 4th place number means that it's still the median. So even changing a number dramatically didn't care. The median didn't care because, again, it only cares about what is the number in the middle. Okay, you can change these other numbers anything you want as long as it doesn't change the number that's in the middle. And that's why we say the median is not very sensitive. Let's compare that to the mean, because the mean does care about every single number, right? The mean, if you calculated the mean for this data set, you would get 9.43, okay? If you calculate the mean for this data set, all of a sudden, look what happens, 102.43. Remember, it's like adding that big frog. The mean is going to be drawn towards it, right? Because it wants to find that center of gravity. So by adding this outlier, we'll call this an outlier. It's an extreme score that is unlike any other. It dramatically increased the mean. If this, let's say, go back to this original data set, if we change the 4 to a negative 4,000, what effect is it going to have on the median? And the answer is none. 9 is still going to be that 4th score. Will it change the mean? Yes, because if we change 4 to negative 4,000, this time the mean is going to be pulled out towards this direction, because now the negative 4,000 is a huge number only in this direction. So the mean is going to be drawn towards that number. And it's because the mean is trying to find the center of gravity. But the point here, as far as sensitivity goes, is that the mean is influenced by every single number. Now, you might think that that's a good thing. Well, sometimes it is a good thing. Being sensitive, sometimes it's a good thing. Sometimes it's a bad thing. So the fact that the median is good, that the median is insensitive, right? Because it doesn't care about all the numbers. It only cares about the middle one. The fact that it's not very sensitive is sometimes good and sometimes bad. So sensitivity can go both ways. Okay? You get the analogy here, the baby dove, very sensitive, right? Okay. I always try and put, some graphics or photos or clip art that kind of illustrate the concept.